construct and understand relative frequency tables for a set of data. So let's do one example of constructing a relative frequency table and then one where we understand and we use it. So first things first, what is relative frequency? Well, we know that frequency is the number of times a data value occurs, right? Just frequency. But relative frequency is the ratio of the number of times a data value occurs. So we can find relative frequency by a fraction. So we will take the frequency of the data value in question, I forgot the word of, and we're going to divide by the total frequency. So you're really working on the ratio. So the part that we care about versus the total. You also might think of this as, right, it's probability. It's the proportion of data that fits in that particular spot. So let's look at this. We are given a frequency table. So we have the values ranging from 5 to 10, right? 5, 6, 7, 8, 9, 10. And then we have the frequencies, 8, 12, 7, 10, 6, 7. Our job is to use this frequency table to calculate the relative frequency. So again, if we think about relative frequency as the data value frequency over the total frequency, well, we know the data value frequency for each one that's given, but we don't know the total. So our first job is to sum up the frequency column. So 8 plus 12 plus 7 plus 10 plus 6 plus 7, and that gives us 50. So our total frequency is 50. Now I can work on each one. So if we go to the value of 5, we'll start at the top. Value of 5 has a frequency of 8. So I take the frequency of 8 and divide by the total frequency of 50. 8 divided by 50 is 1600ths. Now, I generally write my relative frequency as a decimal. You can write that as a fraction, but remember with fractions, we always want to simplify or reduce to lowest terms. And so I find decimals usually just a little bit easier. Now, if the decimals are repeating, or they don't terminate, then you want to probably leave as a fraction so that you are, as accurate as possible. For the value of 6, we have a frequency of 12. So I take 12 divided by 50, and I get 2400ths. For 7, I have 7. My frequency is 7 divided by 50, so 1400ths. 10 divided by 50 gives me 2/10. 6 divided by 50 gives me 1200ths. And last but not least, again, we have a 7 divided by 50 for 1400ths. Now, one thing to note about the relative frequency is that if we total that up, we should get a value of 1 because it represents all, right? So the proportion would be 1. And that's how we calculate relative frequency. Now let's use this. So we're given a relative frequency table, and we're going to answer 2 questions about this. So you'll notice our relative frequency table, the left, our value is the number of dogs, and the right column is the relative frequency. So we can see we have 0 to 5 in terms of the number of dogs, and then the relative frequency of 2100ths for 0, 1800ths, 4600ths for 2 dogs, 800ths for 3, 500ths for 4, and 200ths for 5. So now let's look at the questions. Question letter A. If 200 families were surveyed, how many have just 1 dog? Well, I know that the ratio of just 1 dog is 1800ths. So think about this. If the ratio of 1800ths of the 200 families, of means to multiply. So if we take our relative frequency and we multiply that by the number surveyed, that will give us an estimated how many families will have just 1 dog. So 1800ths times 200 gives us 36. So 36 families would have just 1 dog based off this data. Letter B. If 700 families were surveyed, how many would have how many would have 3 or more dogs? Well, here's 3 or more. So we're looking at 800ths, 500ths, and 200ths, right? All of these together, because 3 or more is 3, 4, or 5. So when I add these together, I get 1500ths. So then we do the same thing. I take my 1500ths, I multiply by the 700 families, and we end up with 105. So 105 families would have either 3, 4, or 5 dogs based on this relative frequency table. So that is how we construct and understand relative frequency tables.